Okay, so I'm looking at number 6 out of the book as our example. So our problem is f of x equals x squared minus 4x minus 5 divided by x plus 1. This was on page 557. Okay, so the first step that we're going to do is we're going to check for our horizontal asymptote. So let me write our steps out here. So the reason we're doing the horizontal asymptote first is it's just easier because we have this thing in its original form. You don't have to do horizontal first, I just like to. So we're going to follow our formula, or our formulas. There are 3 of them. Okay, so we look at a degree of the top. Well, the degree of the top in this case is 2. So if you remember, the degree is the highest exponent. Well, its highest exponent is a 2. The degree of the bottom is just a 1 because we have an x. So degree of the bottom is just a 1. In this case, the degree of the top is greater than the degree of the bottom. If the degree of the top is greater, that means it doesn't have a horizontal asymptote. So no horizontal asymptote. Yay. Okay, we checked that. Our next step is going to be to factor anything that'll factor. So you're going to factor the top part if that'll factor, factor the denominator if that'll factor. In our case, we have x squared minus 4x minus 5. So we can factor this. We'll factor it the way we normally do with our a, b, c. Our a in this case is a 1, our b is a negative 4, our c is a negative 5. A times c is negative 5. The factors of 5 are 1 and 5. We need the biggest one to be negative. The other one's going to be positive because you have a positive times a negative gives you a negative, and they add up to negative 4. So then our factors would be x plus 1, x minus 5. Those are our factors. So we can rewrite our equation then. So now we have f of x equals, so we have f of x equals x plus 1, x plus 5 in the top, or x minus 5, sorry. We have x plus 1 in the bottom. Okay. Step 3 and 4 we're kind of doing together. We're going to find our vertical asymptotes and our holes. So in this case, when we factor, we see that x plus 1 factors out of the top and the bottom. Okay, so we know that there's a hole right here where they canceled out. You see the yellow ones that canceled out? So we need to find out where that is. So what we're going to do is we're going to take the bottom, this x plus 1, we're going to set it equal to 0. Then we're going to solve for x. So we subtract 1 on this side, subtract 1 on this side. We get x equals negative 1. That means the hole is at x equals negative 1, but the hole is like an actual point, so we need an x and a y, not just an x. So what you're going to do is we have up here, we have a simplified equation, right? These x plus 1's canceled, so you're left with x minus 5. Okay, so down here we say, okay, we have f of x equals x minus 5, which is an equation of a line, right? Like our mx plus b. Let's see, y equals mx plus b. The only difference is we know it's x minus 5, but we do have this exception, right? There can't be anything at this point at x minus 1, x equals negative 1. So what we need is we need the y coordinate for that one too. So we're going to plug that in. So we have f of x, so we're going to say f of, but instead of x, we're going to say negative 1. And then wherever there's an x, we're going to plug in our negative 1. So f of negative 1 would be negative 1 minus 5. Well, that gives us negative 6. So then our actual coordinates of our hole would be at negative 1, negative 6. So then, after that, we're going to graph it. There are other things we're going to do, but right now what we've done so far, we would graph it from there. Now, what we would normally do is we would want to find our x-intercepts and our y-intercepts. So let me go ahead and do that too. So if we want our x-intercepts, you're going to set your y equal to 0 and you're going to solve for x. Right? So this is, we're trying to figure out where it crosses the x-axis. So in this case, we're going to use, we could use either one of these equations. I would actually use just our simplified one in this case. So we're going to say f of x equals x minus 5. But now our y is a 0, so this is 0 equals x minus 5. So if we solve, then we get plus 5, x equals 5. So our x-intercept is 5. Now, we also want to find where it crosses the y-axis. Well, since this is a line, we have our mx plus b, we can already get our y-intercept, but let's pretend it wasn't a line. We'll just use the generic formula. So your y-intercept, you're going to set your x equal to 0. So you're basically doing the opposite. So if you want x-intercept, your y is a 0. If you want the y-intercept, your x is a 0. So in this case then, so we're going to say y equals, and we have our x minus 5. But we make our x is 0, so y equals 0 minus 5. So our y-intercept equals negative 5. Which makes sense because our mx plus b, our b value was a negative 5. Okay, so we need that. So then we're going to take all of these things. Okay, so step 5, we're going to find x-intercept. Which, those are really our zeros, right? Step 6, we were going to find our y-intercept. So this is, we're going to make x equal to 0. Step 7, we're going to graph. Finally. Okay. So if I copy all of this over here, so let's see. Okay, we have f of x equals x minus 5. I'm going to copy over our little simplified version. So f of x is x minus 5. We have a whole, and that was at -1, -6, I believe. Yes. -1, -6. Let's see, we don't have a horizontal asymptote, we don't have a vertical asymptote. So, no horizontal asymptote, no vertical asymptote. We have our x-intercept is at positive 5. Y-intercept at negative 5. And we're just going to come in here and we're going to graph it. Okay, so here's our coordinate. We have our x-intercept is our y-intercept is negative 5. So 1, 2, 3, 4, 5. We're going to graph this just like we would a line. So this is mx plus b. So our slope is going to be a 1. Our b is negative 5. That's our y-intercept. And then we also have our whole. That's at -1, -6. So I'm going to go ahead and put me a hole right there. And now, 1, 2, 3, 4, 5. That's our x-intercept. I'm going to draw my line. So we have a line going this way and going this way. And it has our hole. Ta-da! So that's what our graph looks like. We could actually extend this line out further. That's our graph. So this whole thing, we wouldn't really be able to tell it from looking at the original. So the original, we have this whole x squared, all of this. So just looking at that, it doesn't look like that's actually the equation of a line, but when we simplify everything down, it kind of is, right? See, here we go. We have our equation, we have our line. The only exception, or the only weird thing about this line is it has a hole right there. So this is, that's the only difference between this and just a normal line.